All right. So, yeah, so I muted myself again. It's all right. So, guys, welcome to the live session. My name is Ram, and today's session is going to be about launching a Spring Boot Java app using Docker. All right. So, that's what we're going to be doing today. So we'll basically be going through a theory about Docker, about Spring Boot. We'll learn about what these things do, and we'll try to deploy a Spring Boot Java app using Docker. There are a lot of words. If you're getting confused, it's all right. It's totally fine. Even I got confused when I kept on hearing about Spring Boot and Docker. But over time we learn and we understand things. So that's what we're going to be doing in this live session. But before I do begin, I need a confirmation from you guys so that I can make sure that you guys can hear me and see my screen very well. So I would love a confirmation from you guys. All right. So I don't see any confirmation, but I do see Sanket saying, please start the session. All right. So guys, this is what we're going to be doing today. Basically, yes. So Ravi is like, you are loud and clear. Hey, hi Ravi. Welcome back. I see you're a regular. I do remember you. You ask a lot of cool questions. All right. So, guys, this is our session, but let me just show you Great Learning again. So, for all of you guys who don't know about Great Learning, here, Great Learning, our institute, we've come up with something called Great Learning Academy. So, if you're interested in getting any kind of certification, feel free to do so because these certifications that we provide are free at Great Learning Academy. This is an initiative that we started for COVID, and we have a lot of different domains from which you can choose your topic. Like it can be data science, machine learning, artificial intelligence, IT and software, or cloud computing. A lot of different options you guys have, and these courses are completely free with no catches. You just enroll for the course, complete the quiz, and once you complete the quiz with a good mark, you're going to get a certification. That's definitely going to help you guys. All right. Okay, so with that out of the way, let's come back to our session. Okay, so I see that my chat is a bit, lively. I see Ravi is like, yeah, I love to learn from you, sir. Well, thank you. I love teaching as much as I can teach you guys. And then we have someone new over here. So we have Satinder. Yeah, welcome, Satinder. I hope you enjoy this session. If you are new to Docker, then please go ahead and check out our Docker tutorials or introduction to Docker. I've done a lot of live sessions, even in Hindi. You just type in Great Learning Docker in Hindi, and you find a video that details everything about Docker. All right, so Docker is my expertise, and I try to teach you guys about it. So this is what we're going to be doing, guys. So I'm going to go through a brief history about Docker, brief history as in, detailed comprehensive overview of Docker. Then we'll talk about Spring Boot. We'll talk about the theory, how Spring came up, what Spring is, how does it help us, and then we'll try to deploy an application. So let's quickly start off by discussing why containerization. So containerization is a technology that we use a lot. So if you guys already know about the stand, don't worry, I'm going to go really fast for the Docker part because I know a lot of you have already listened to this again and again. So, but for those who haven't listened, don't know what Docker is, please do check out the Docker video that we already have. We have a lot of introductions. So standard delivery pipeline, right? So in software development, standard delivery pipelines look something like this, where the developer writes the code, he sends the code for building, and once it's built, the tester tests it, and once the tester approves it, it goes ahead for deployment. All right, so we have one more person, Sandeep, saying, this is my first session too. Well, welcome, Sandeep. I hope you really enjoy the session. You take something out of it. Okay, so this is a standard delivery pipeline. So what kind of issues can occur over here? So guys, in standard delivery pipelines or in standard software development, right? Uh, the issue that usually can come up is the compatibility issues. We have so many different projects that people are working on in so many different fields, even inside one company. A company as large as Tesla can also have a lot of different developing teams, a lot of different testing teams, and all of them have to exchange their projects to do this specific or designated task. Like the developer has to develop, the tester has to test. Now, standardization is important because if you don't standardize what the tools and methods you're using, you can have compatibility issues. Let's say the developer is using one set of environment, like he's using Ubuntu as his environment and he's coding over there, and he's using a specific version of a tool. Let's say he's using Java 11 or something, but the tester is using only Java 8 and he's using another operating system. So you can see that there are a lot of differences in their environments. So when they take each other's code, like if the developer sends the code for testing purposes, the test will try to run it on your system and it won't run because of these kind of small issues where you have slightly different versions or different things and you have a different environment. So software is finicky like that. It runs only on specific things, and that's why we want to make sure that there is a standardization. Now, normally we can't do this very well implemented because requirements are always changing, and the developers have to develop according to those requirements, right? If a new software comes in that allows you to make a tool much better, you will obviously go for that, right? So the developer has to keep up with the requirements. So that way the standardization can change completely. Yeah, just one second, guys. There's a lot of disturbance in my background. Let me just clear that off. Hello? Yeah, I'm so sorry, guys. I hope the background noise is gone because I want you guys hear as much as you can without having any issues. Yeah. So like the moderator is saying, if it would be nice if you guys can give me another confirmation that it's loud and clear, so I can move on. Hello, testing. Okay, yeah. So now we're back. So we have a first question. So that's really good. So Ravi is like, so how can we overcome the issue that we are facing with the standard that we're using Docker? So yeah, yeah. So this issue that I've been talking about, the compatibility issue, right? We resolve this by making use of containerization. Now, containerization is really cool new technique that we make use of in software development. Well, it's not really new. It's like almost a decade old now, but it's really cool. Like a lot of companies are adopting it. So containerization, it basically what it does is it wraps up all the important parts of your software development process. Like it takes not process the software. Like when you want to make a software, you need your code for it, you need your dependencies for it, and you need your tools for it. So what containerization does is, as the name suggests, it contains all of those three things. It takes the environment, it takes the software or the code, and it takes the dependencies. It puts them in one container or a box. And instead of the developer sending the code itself, the developer sends the container. So inside of that container, all of those things happen, where the building process, it happens inside of that container. The testing process, it happens inside of that container. The deployment process, it happens inside of the container. So this way we're containing it. This way we're creating a layer around the software so that it does not have to mind what's going on in the host environment, what's going on in the tester's system, or what's going on in the developer's system. So that way we remove that compatibility issue headache. So both of them are like, yeah, this code runs totally fine on my system and we have no compatibility issues. So this is what containerization does for us. And that's when I talk about containerization, Docker is what comes to our mind, because Docker allows us to create these containers, these things that in which we can put all our code. So if we look at it again, you can see the code, the libraries or the dependencies and the environment taken together can be put inside of a single deployable unit that can be used on different systems and servers. That's what a container is. And when we talk about Docker, Docker is something that allows us to create these containers. All right. So hope that's clear. Now let's talk about why do we need these containers. One reason is something I've already stated: consistent development environments, to maintain some standards and to keep a very consistent development environment, that no effect from the external host system is happening to the software. You have the same environment all across your pipeline. All right. And another thing is microservices. Now, I want to emphasize on microservices in this lecture, because when we talk about Spring Boot also, Spring Boot is something that is used for deploying Java applications as microservices. So that's what I want to emphasize over here. Now, containers and Spring Boot both do that. Where what is microservices? So microservices is basically a type of architecture implementation for deployment purposes. So let's say that you deploy a software. How do you deploy it? Like, can somebody give me what kind of, any kind of understanding they have in the chat? Like, not how you deploy a software, like what is the software? Like, is it a single file, or what happens during the deployment thing? Like, how are you deploying it? Can somebody give me a short, concise answer? Guys, try to keep the chat interactive. Ask yourselves questions and talk to each other. Yeah, it's pretty cool when that happens. So I get an answer from Sandeep, a package. So yeah, you're right. So it's like a package that you deploy, right? That one package will have everything the software needs. But that's the thing. When you deploy the software, okay, we have more answers like var, rar, jar. Yeah, you're right. So you have var and jar files that you use in Java. If it's Java application, I create a jar or war file and deploy it on the server side. Yeah, you're right, totally, Ravi. So that's how you do it, right? When you're using Java, you create a .jar file or a .var file and you deploy it, right? But when it comes to a large organizations where you don't have simple apps, where you have so many different things, like you have so many different components to an app, like Ashwin is saying, all the components are compiled and packaged. So that way, all your components are separately compiled and separately packaged. This is because we want to manage these things separately. We want to deploy them together, but manage them separately. So we do it in a microservices type of architecture, where you guys can see if an application has 5 parts to it, these 5 parts can be its features or its functionalities. Then these 5 parts of functionalities will be deployed separately but together. When I say separately, I mean that they won't be in the same package. When I say together, I mean they will be connected to each other. So that's your microservices implementation, right? So that's what Docker containers also help us to do. They allow us to keep all of these different parts of software in different containers and deploy this application as a set of these containers. So you would use some kind of orchestration service in this scenario. And an orchestration service here would basically allow you to manage these containers. It will allow you to scale it up. It will allow you to monitor it and a lot of different things. So yeah, Ravi, based on the language, you will combine the code and its dependencies as a package and put it onto the server. Yeah, you're right, exactly. With Java, how do we do it? With Java, we basically take the Java code, we build it using Maven, Gradle, or Ant. We make a executable or an artifact, and then we put it on some server. Like if you want to deploy a .war file, you use Tomcat, right, to deploy it. So, that's how you do it. Sandeep is saying EAR for enterprise. Yes, you're right. EAR is used for, Java enterprise applications. All right. So this is what microservices is. You're basically trying to deploy your software in multiple chunks. And this is very beneficial because you can manage and handle all of these different parts very easily. You know where each part is located and you know what is going on with that part because you monitor them separately. You see how well they're doing. If let's say suppose one of your features of your application is the payment feature and your payment feature goes down for whatever reason, let's say a lot of people are buying at the same time and your server just can't handle it, so it breaks down. So you know that something has gone wrong because you've assigned a lot of monitors on it, and then you see that it's gone wrong, and then you try to fix it. You fix that problem. So that is one advantage to it. Another advantage is the deploying. It makes deploying very easy. It makes it a very hassle-less process where you can just easily deploy whatever part you want, easily update each part according to what's going on in your development process. Let's say only one part has been updated and you only want to update one part, you just update that one part without touching the other things, right? So this is why microservices type of implementation is important. And that's what containers allow us to do also. You just keep all of these different chunks in separate containers with whatever they need to run, and you deploy them all together. And when you run these containers, they don't run like without any connection. You always have some kind of network in which you all connect all of these containers. So if you're using some kind of orchestration tool, let's say Kubernetes, you will have all of these pods and all of them will be connected to each other using your networks, right? Okay, so now let's move on. Let's talk about Docker again. So Docker is basically something that enables to do all of this. It enables to create containers. It enables to keep consistent development environments. It enables to allow us to implement microservices. So it helps us to basically develop, build, deploy, and execute software in isolation. So you have the Docker taking an app, putting in a set of the containers, and deploying it. So that's what it does. So let me just quickly move on. All right, so Docker installation and setup. Actually, you know what? I'm going to keep this for later because we'll see what its purpose is. Yeah, so Docker environment, just to basically help you guys revise. So Docker environment has many different things: engine, the object, the registry, compose, and so on. One by one. Engine is basically something that allows you to run all the processes in Docker. Objects are what you utilize to do Docker things like create images, create containers, create volumes, create networks, all those kind of things. And registry is the location where you store your images. Now, when I say you work with containers and you share the containers, you don't actually share those containers themselves. Containers are something, they're runtime thing. They're happening in your system. What you share is you share the blueprint of those containers, and people in the software development pipeline, they run the images into containers. That's how they do it. They don't just transfer the containers themselves. All right. Then you have Docker Compose, which is a service that allows us to launch multiple services or containers at the same time. Then you have Docker Swarm, which basically allows us to manage these multiple containers. All right. So today we'll just be focusing on normal Docker. We don't need to think about all these complicated things. Architecture, let me just quickly go through this. So Docker build tells daemon to build an image. Pull basically asks us to pull an image from registry, and run basically allows it to run a container. All right. Now let's talk about Spring Boot. So how many of you know about Spring Boot? Go ahead and tell me in the chat. Or do you guys know about Spring? Or how many of you work with Java? Or have worked with Java? So Manish is asking, is Docker a sort of VM or does it run on a VM? So Manish, you have an apt comparison over here. Docker is sort of a VM. It's like a very lightweight VM where you don't run the whole thing, where you run only the basic necessities that are required to run a particular operating system. Like you don't take the whole Ubuntu operating system. You don't take the GUI and everything, the graphical user interface or whatever browsers is using. You're just taking the main basic necessary parts that are required to run something, and you run that in containers. So Ubuntu image in normal life, like it would be like 2 GBs or 1 GB, and in containers it will be like 73 MB, like that. So I hope that gives you a clear idea. So yes, they're kind of like VMs, but they aren't VMs. All right. So Ravi says, I am aware of what it is, but I have not worked on it. It's all right. So you guys will get a glimpse of it. Sandeep says, I've been working on Spring Boot for years now. So if you've been working on it years now, then you'll have a lot more knowledge than me about this. I'm more into Docker. So this is a learning experience for you to how to deploy things on Docker, right? And Ashwin says that he's worked with Java. And Kajal is asking, what is this Spring Boot, sir? All right. Okay. So some people have worked with it. Some people don't know what is Spring Boot. Like Ashutosh says that he's worked with it. And Madhuri says that she doesn't know what it is. She's asking, what is Spring Boot? All right. So that's all right. So some people don't know. Some people do know. Let me just give you guys a clear idea. Java is a programming language that you use to make a lot of different kinds of software. You have different kinds of software that you make from it, like desktop applications, like your normal software, your this thing, web-based applications, and many more examples. All right. So Java, when you write in Java, right, you sometimes need to make use of certain libraries and certain functions, and it takes a lot of effort to write these libraries and functions by yourself. So instead of doing that, what you do is you make use of frameworks. These frameworks basically provide you all of those libraries, all of those frameworks, just with a click of hand. Now, if somebody has already worked with Spring, can you guys confirm this? Is this what you guys do with Spring? From my understanding, that's what Spring is. It's a framework that allows us to basically, run Java modules, a lot of different modules that are there in Java, that you use with Java to create applications. It's like .NET, right? But it's a little different than that. It's more of a framework. So Ravi saying Spring Boot is basically a framework, yeah, that is used for developing applications in Java. It makes development of web applications easier. Yeah, exactly. So that's what I also know about it. Like it's basically used to create web applications, and makes all of the process very easy. You don't have to go into a lot of configuration details, where you don't have to configure a lot of the smaller details. And if you do have to configure all of the smaller details, you can do it. It gives you the flexibility to change what you want, because your requirements will always change, right? And based on your requirements, you can make those changes, but it isn't necessary that you have to do it. It makes living with Java and making Java applications a lot more easier. Okay. Okay, guys, whoever has worked with Spring Boot, please feel free to correct me if I've gone somewhere wrong. Okay. Yeah. Okay. So now Spring has like a lot of different things, and Spring Boot is one of those things. Now, Spring Boot is a part of Spring that allows us to deploy applications. It basically makes Java application deployment very easy and a very smooth process, right? So that's what Spring Boot helps us to do. One second, guys. Yeah. So in actual like proper enterprises, right? Developers need to deliver software very fast, and they need to do it very very robust way, if that's the right word. And they need to do it in such a manner that in future needs to be scalable, and it needs to be reliable also. So that's where they make use of Spring, because it's a modular Java framework that is very lightweight. So you can see that you only have to concentrate on specific modules, that you don't have to think about anything else. So if you're working with a specific module, you just work with that module, and it's very lightweight. And it basically gives you a lot of support for modern web applications that you want to develop. And you have supportability for a lot of different technologies with Spring also. All right. So yeah, so Spring is out of the way. Now let's just concentrate on Spring Boot. So Spring Boot, you basically use to deploy Java web applications as microservices. So basically, Spring Boot allows you to deploy Java applications without, serverless. So you don't have to use Tomcat separately. You don't have to download Tomcat separately. You can just take your Java application, and if you're using the Spring Boot plugin, then you can directly just deploy your Java application without needing Tomcat. It has inbuilt, basically, Tomcat, right? So that's what Spring Boot is. And again, in basic, it basically makes our Java deployment very easy. So it comes to that DevOps part, or where it comes to the deployment part, where you have to think about how you're going to deploy something. You have to make sure that your deployment is very smooth, because that's like the main thing when you have to deliver a product to your customers, right? So you need to make it very smooth. That's why make use of something called Spring Boot. All right. So now that is out of the way, let's go ahead and deploy a Spring Boot Java app with Docker. All right. So guys, this is what I'm going to be doing over here. I'm going to go ahead and launch a virtual machine on AWS. So we'll be using the EC2 service. Let me just open it up. And on that, we're going to deploy a very simple Spring Boot application. Okay. Using by itself, and then we'll use Docker. All right. So let me click on launch instance. Let me come down. We'll open up Ubuntu. All right, so we'll be using t2.micro. That should be enough. We'll configure security group over here. Yes, Ravi, you're right. It's having like a inbuilt thing, so it doesn't really need to, make use of an external web server. It just does it by itself. It comes inside of the jar itself. It's like a very powerful jar, you can say, in a way. All right, so we have set up our VM. Now let me just launch it. So guys, we'll be using Ubuntu VM. So we'll be launching it on Ubuntu in Linux, okay? Yeah, sure, you can, if you want, you can do the demo along with me. All right, so what we're gonna do first is we're just gonna update the instance. All right. So normally, if you're a developer and if you're testing things out, I think you would be using an integrated development environment. I'm going to be doing all of it manually without using an IDE, just doing it on Windows, Ubuntu. You have plugins for that. Now you can install Spring Boot separately and make use of it. But what we're going to do is we're going to install Maven, and we're going to use a plugin that is available through Maven to work with Spring Boot. Okay. So the first thing we are going to do is we're going to set up our directory over here. Yeah, so Nikhil says, I'm currently learning Spring and Spring Boot. It's awesome for Java web application, better than servlets and JSP. You're right, man. It's totally cool. When I heard of it, when I started, when I used it for the first time, I was like, oh, this is like really smooth. You just have to do one thing and it's done. Okay, so what we're going to do is we're going to set up our directory. So first I'm going to create a project directory. All right, so let me just head inside the project directory. And inside of this, we're gonna set up the source and the file, the folder in which we're gonna have all of our files. So let me just do mkdir again. So we're gonna create main, and we're gonna go ahead and do Java, and then fun. Fun is the name of my directory. Okay. So now that we've done that, we're going to go ahead and create a pom.xml file. Since I know a lot of you already know how Java applications work, you know that you need a pom.xml file to build it and to make it into an executable. So for all of those guys who don't know what Java is and you don't know how to work with Java, so this is what happens. So you normally, when you're working with software development and deployment, right? You don't directly just use JRE for it. What you do is you basically write your Java code. You use a build tool to build the Java code, because your Java code won't be alone. You'll need some dependencies with it. It can be some kind of function that you're using. It can be some kind of plugins you're using. And for that purpose, you need to build the software. So the building process is basically taking this code and you're putting it in one place and you're putting the dependencies with it. And once you do that, you make it into a single executable file. Like a lot of people mentioned in the chat, you have these .jar files or .war files or .er files. These are the build files. These are the artifacts or packages, whatever you want to call them. They're, they're basically the software. Your code isn't alone the software. Your software is basically your code with the tools and dependencies that it needs. So those are your .jar files or .war files or .er files in Java's case. All right. Okay, so we have created this directory, right? So now what we're going to do is we're going to create a file called pom.xml file. So pom.xml files are basically files in which you mention how you want your code to be built. Like you want to mention some specifications on how you want your code to be built, right? So to do that, you create a pom.xml file. So let me just go ahead and get my configurations. I'll just show you guys the configuration once I paste it in. Hey, hi Kamal. Hope you are enjoying the session. All right, so guys, this is my pom.xml file. You can see my model version over here. The group ID I'm using is org.framework. Artifact ID is going to be GS Spring Boot Docker. All right, so okay, so we'll let it be that. The version is going to be 0.1.0. All right, I just want to change the artifact ID. All right, so we'll just keep it Spring Boot Docker. Okay, so version is going to be 0.1.0. This is basically the group ID again. All right, let me just come down. So using Java 1.8, and these are the dependencies. So in the dependencies, you can see that we are getting the Spring framework boot. Sorry, Spring Boot framework, and we're going to be using it directly to run our project. So using the framework, we're basically getting the using this file, we'll be downloading the Spring Boot plugin and we'll be making use of the Spring Boot plugin once we've used basically downloaded the plugins, right? So to do that, we'll have to make use of Maven. Now Maven is a build tool that helps us to do this. Okay, so let me just save this. So we've made a pom.xml file. Now the next thing we need to do is basically install Maven in our system. Okay, to install Maven, what we're going to do is actually first let me just make the file. So right now we have the src. There's a source. Yeah, main. Okay, over here what we're going to do is we're going to create a app.java file, or let me just name it application. Okay, so let me just paste the code that I have over here. So this is a very simple code over here. You guys can go ahead and copy this too. And you know what? I'll tell you guys a very easy way to get a sample package. There's something called Spring Initializer. You can generate a sample package for yourselves. All right. So, or if you want this code, go ahead and check out the documentation. You can even find it over there also. So let me just copy this code. What this code does is basically prints out the statement, hey guys, hope you are enjoying the session. So that's what it's going to be doing. And we're going to be doing it by using Spring Boot. All right, so let me just save this. Java application. All right, so we have done that. Now what we're going to do is install Maven in our system. So let me just head to OPT. And over here, we are going to install Maven. To install Apache Maven, we're going to get the latest version. Let me just download it from here. Copy the link address. Use the wget command to get the Maven file. Right, so we just need sudo access, root access. So it will install, download Maven for us. Okay, so Dave has a question. Docker is a software containing packages. Can it be compared with .NET framework type? No, see, Docker is it's a tool. Okay, so let me just make it clear. It's not a software containing packages. It is a tool, Dave. It is a tool that allows us to create containers. Like if you had watched the earlier part of this session where I explained what containers are basically they're boxes, they're self-contained environments. So Docker is a tool that allows us to create those self-contained environments. And inside of those environments, we can keep our code, we can keep whatever packages we want, and we can do whatever we want inside of those self-contained environments. And we can deploy it or whatever the thing is. All right. Okay. So that's what Docker is. So it's not comparable to .NET because you'll be using .NET with Docker. All right. So let me install Apache. Let me just unzip it right now. Yes, root access. I keep on forgetting to get root access. Okay, so if we do an ls, we have Apache Maven. We head to bin. Okay, over here, if we do a /mvn, our version, it should not work because I have not downloaded Java. Yeah, so we don't have Java. So what we're gonna do is we're gonna go ahead and install Java over here. So sudo apt install open jdk -8 -jdk. When you're installing Apache Maven, right, you need Java for that. To always make sure that you have Java, you can check if you have Java or not. One second. Sudo. One second, let me just try this again. So we'll just update the instance. Okay, now let me go ahead and install Java. Sudo apt install open jdk -8 -jdk. Yes. So if you want to check what version of Java you have, just type in Java -- version in your system. You can do that. I'm using this method to do it, Ravi, because you know this will get you the latest version. What happens is sometimes your package manager, right? So the Debian, whatever package manager we're using for Ubuntu, I forget the name, will basically you have one of Maven, in its repository from which you can pull, but it may not be the latest version or it may not be your preferred version. So if you want a preferred version for Maven, right, what you can do is you can just type in whatever version you want, Apache Maven on Google, and download that version. Right now we're getting the latest stable version, that is 3.6.3. Okay, so once we've gotten Maven over here and we have Java, if I do a /mvn version again, you guys can see Apache Maven is working because we have installed Java. All right, so now what we're going to do is we are going to make this global. To make this global, we need to we're going to need to put it in the path variable, environment variable, so it can be accessible from everywhere. Export path equal to $ path colon opt Apache. Just copy it directly from here. All right, now let's just test this out. All right, so it's working fine. So basically we made Maven available from everywhere. Now we're gonna head back to our project folder. Okay. All right, so basically we've installed Maven, and what will happen over here is basically Maven will read through the pom.xml file. It will understand what are the plugins, and one of the plugins is going to be our Spring Boot plugin, and it will download it, and then we're going to run our Java app directly without having to install Tomcat over here. So let me do that. We can do mvn package. So this will create our package. And java hyphen jar target slash spring boot dot jar. Okay, so it will start packaging it. So there are some life cycles within Maven. So first what happens is it compiles. So first it will compile your project. Actually, first it will download all the dependencies after it reads through your pom.xml files. If it understands that there are certain dependencies it needs to download, it will download them from central repository or whatever location you've mentioned. And once it does that, it will start compiling your project, basically, turning the .java files into .class files. And once it converts the .java files to .class files, it will perform all the test cases if you have any test cases. And once it done that, it will go ahead and package your thing. So you can see over here, it tells that build was successful. Okay, so if we do an ls, we should see a target folder now. So let me go inside target folder. Okay, so we have our .jar file over here, Spring Boot Docker 0.1.0. So this is the one that we created. Okay, so this should have basically run it. I wonder why it didn't run it. Let me just try using another command. Mvn spring boot run. Let's try this. All right, so now we're basically running it. Okay, so we have the application running at the port 8080 by default. Okay, so this is basically us running our app using Spring Boot. So all I did was use the command mvn spring boot run. Okay, all right. So let's just open up our browser over here. Let me copy the IP address. Now, if you're using your own system, you need to do localhost. I hope you guys are aware of it. Then we'll head to the port 8080. And we see the message that we wanted. Hey guys, hope you're enjoying the session. So guys, this is our basic deployment of the Spring Boot Java application. But this was without Docker, and you guys can see over here that it tells us that it was complete initialization and everything. And you see, normally if we wanted to do it, we would have to use Tomcat and everything, etc. But what Spring Boot does over here is it does it by itself. It does a lot of automatic configuration by understanding what our environment is. And once it understands the environment and sees our dependencies, it basically deploys it, right, according to all of those things. Okay, but if you want to configure a Spring Boot to have a specific thing, you can do that still. Okay, so this is our normal deployment. Now let's go ahead and try this with Docker. So with Docker is the one that we want to check out because Docker is really cool and a lot of people use Docker. So my reasoning is Docker is really cool. What is your reasoning? Okay. So guys, to do this with Docker, what we're going to do is we're going to create a Docker file. So Docker files basically allow us to create Docker images. So using the Docker file, we're going to create an image and then we're going to run that image to become a container. And from that container, we're basically going to run that container, and within the container, all of our app will run. We're using Spring Boot. Okay. So first, I'm going to do a nano Docker file over here in the same location in project itself. And inside this Docker file, I'm going to go ahead and write my requirements. So first, I'm going to use an image. So I will be using the OpenJDK image, OpenJDK colon 8 hyphen JDK hyphen Alpine. So we're using an OpenJDK Alpine image. Okay. Now I want to mention an argument that is jar underscore file equals to target slash star dot jar. So this is basically me assigning argument over here that I will be using later. That argument equals to the target /star. So what this is basically going to the target directory within the current directory. So it will check if there's a target directory in project, and if it finds it, it will go inside and it will look for a .jar file. It will look for all the .jar files, okay? And it will put them in the jar file argument over here. All right, so once we've done that, we're gonna go ahead and copy this jar file. So the copy instruction basically allows us to copy files from our source directory. So let me just type in jar file, and I'm going to mention the location app.jar. So this is going to be the location inside my container. Enter. And now we're going to use the entry point command to run a command. Entry point instruction. Entry point braces, close braces. Inside of the close braces, we're going to mention the command that we want to run at the starting of the container. So that's what your entry point command is used for. And within the close brackets, you can mention all the variables that you want to use or parameters. So basically, you're typing the command. All right. Okay. So let me go ahead and save this. Control O, Control X. All right. So we've created a Docker file. Now we just need to install Docker. So Docker installation is very easy. You just need to type in sudo apt install docker.io. So this time, Ravi, we're using the package manager file because it's going to be very easy. -y. Also, our requirement doesn't need us to get the latest stable version. Once we get this, once we get Docker into our system, we're gonna go ahead and run this file using the command docker build command. Okay. And when you're doing the docker build command, you can, mention the specific name that you want for your image. And if you want to upload it to Docker Hub, you know the format. You need to enter your username first and then your image name. So let me do docker build. Okay, actually, let me check the Docker version over here. All right, Docker install. Now I'll do a Docker build and Docker build. I'll give the name for this. Now this is my username for my Docker Hub account. That's why I'm giving this. So I can later upload this image. You can have your whatever your username is. Sprint boot image and then dot. All right. So let me just create this. Okay, yeah. So we need to get root permission. So basically this in the end is mentioning the location of the Docker file. Since I mentioned dot, it will look in the current directory itself and it will create the Docker file. But if you to mention the pathway to your Docker file. So you guys can see all the steps happening. First, it basically got the OpenJDK Alpine image. It pulled it into our local system. And once it pulled it, it went to step 2. That is basically assigning the jar file argument with the actual jar that we have created. So you can only run the build command after you created the package, the .jar package using mvn package. Okay, so I would recommend you guys follow the same steps if you're watching the video after the live session has been completed. And then your step 3 will happen where it will copy the jar file using this command and it will take it from the source to the destination. So our destination is going to be app.jar. All right, and then in entry point we're basically going to be running the command when the container is created using the command java jar app.jar. All right, so once it's done, we have created a Docker image. So if you do use a Docker images command. All right, so it use a Docker image command. You guys can see that this is my image that has been created over here. Okay, and for the person who's asking me, is it asking a lot about Docker? You can see that Docker, it's a lightweight thing. It's very lightweight compared to your actual images. Okay, so now we've created a Docker image for our application. We can go ahead and basically deploy this or run this. So it's a very simple command, that is sudo docker run. We're going to mention the port at which we want it to run. I'm going to mention 8080 because it's pretty cool. And then we are going to mention our image name. Let me mention the image name. Now, if you want this to run in background, you can go ahead and mention the -d tag to run it in the detached mode. But I'm just going to enter like this so you guys can see the whole process of what's happening here. You can see that Spring Boot is being activated. It will check for a profile. If you guys have a profile, you can enable those profiles also as a command. Okay, so basically it started to run our app. You can see that Tomcat started on the port 8080 and our application has started over here. So if we come back and let me just do it in another tab so it doesn't feel like it's cheating. Copy, hopefully this runs. All right. So you guys can see, hey guys, hope you're enjoying the session, has now been deployed. So this is your Spring Boot Java application deployment using Docker. So what you need to take out of here is basically how you can create your Docker file and how you can run it. And you guys need to understand that it's very simple to do so. Now it may look complicated if you're not acquainted with all of these different technologies. Then I would definitely recommend checking out all our other videos that do tell you about Docker and Spring. And once you've done that, you can come and watch this session again or this video again and try this out. So it's very simple and it basically helps the developers and whoever is deploying, doing the operations team or the DevOps engineer working for the company. It makes it a lot more easier. So Dave is saying, yeah, got a bit delayed while joining session. Don't worry, Dave. You will have this session available after the video, after the session has completed. You can come back and always watch it. So there's not a problem over there. All right. So this is our basic deployment. Now it wasn't anything fancy, but I did want to show you guys that even it's a very simple process where you just have to understand the very fundamentals of Docker and Spring Boot, and you can just deploy an app. Now, if you're completely new, you can follow the same steps. And if you want the code, what you can do is we can make use of something called Spring Initializer. So it basically allows you to get sample codes and you can create your own Maven files. So just go to Google, type in Spring Initializer IO or just type Spring Initializer, the first link that comes in, right? See, it basically tells you that it generates Spring Boot project with just what you need to start quickly. So if you want a quick start, you can just click on Spring Initializer, open it up, and it's been updated. So you can see that you have a lot of different, configurations that you can do over here. You can choose a Gradle project if you want. So if you're working with Android, you can go ahead and do that. Or if you want Maven, web-based applications, then you can just click on Maven over here and choose your language. So again, Spring works with Java and Kotlin also. So if you want, you can use either Java or Kotlin, or there's a Groovy option also. I did not know about this. And over here in Spring Boot, you can see what kind of version do you want for it. So I'm going to just let it be the latest version. And group over here, you can configure these details also. I'm going to leave these as default because it already has the demo project that we want. And you can see the packaging type you want. You can get the jar packaging or the war packaging. And you have the Java versions also. So if you're using 8 version or if you're using the 11 version, you can go ahead and make use of these. Okay, and if you want, you can explore the whole directory also. So just click on explore over here and it will show you what all you'll be downloading. So it will show you the pom.xml file, and you guys can scroll through the pom.xml file and you can go ahead and copy this directly. So it will copy all of the code and paste it on your own system, or if you're downloading it, then you can download it also. And you will see the source code files also over here, and you can see the demo application.java. So this is again another demo code that allows you to deploy Java using Spring Boot, and the resources that are being used, and this is the test files. All right. Okay, so that's our session, guys. Now feel free to ask any questions. I'll answer them, to my ability. I can answer them. Okay, so we will go ahead and change this to Q&A for the last 5 minutes. So I was really happy that a lot of people asked questions, and I know a lot of you are already acquainted with what Spring Boot is. So today, at least, I managed to help you understand how you can deploy it using Docker. All right. So any questions? I'm ready to take them. About if you want to ask about great learning courses that we have or any tutorials that you guys want to hear about, I can tell you guys about that also. Or do you have any suggestions for future that you guys want to see a session on this particular topic? I'll try to come up with a session on that particular topic also, if you guys want. So Sandeep is asking, Nice session to get Spring Boot on Docker quickly. Please have a session to help with enterprise level configuration. All right, Sandeep, noted. I'll keep this in my list. And when we do get to it, you'll be notified if you subscribe, right? So, a session to help with enterprise level configuration. Okay. All right. Anything else, guys? If you guys don't have any questions, then I will go ahead and end the session. Okay, so Ravi is saying, Sir, I am getting this error copy failed, no sources files were specified when I execute. Okay, so Ravi, I assume what is happening over there is you don't have any source files. So that means you probably don't have the project. I mean, yeah, I will try to get this code to you guys, but it's already available. Just go ahead and check out the documentation. You can find the same code. It's very simple. You can just copy the code and follow the process. But it says that no source files were specified. So let me just open up the Docker file again. So over here, right, you need to mention the location, and you need to make sure that there is a .jar file. So if that is there, then it should not give you that error. Right now, in my target directory, you can see the .jar file. And if you have the target directory and everything, then you need to use the mvn package command, right? This will basically create a .jar file. Okay, so this will allow you to create a .jar file. All right. And if you want, just use the initializer. It already has a Maven file, the pom.xml file, so you can directly use this also. Okay, just type in mvn package and all the commands that we use. Sandeep is asking drawbacks of Docker. So Docker's drawbacks. So as a tool, I mean, I'll be honest, I've used only Docker for containerization purposes. So I don't see that many drawbacks for Docker. So yeah, so I can tell you one drawback for Docker, Sandeep. It's that you don't have every functionality that you want. It gives you the flexibility, but sometimes you don't want the flexibility. You want a quick start, and sometimes you don't have that. But you can do that if you have an image for it. So that's the thing. If you want specific requirements to be fulfilled, you create an image for that. You have to do it yourself. I can tell you the drawbacks of Docker Swarm. Now, Docker Swarm is an orchestration service that a lot of people don't use. Only it's used on a smaller scale. Most people use Kubernetes because Kubernetes is a much more stronger orchestration tool. But even though they use Kubernetes, they still make use of Docker. Docker is such a cool tool that it's a lot of different people use it, and they use it to the best thing. And Kubernetes also uses Docker to create its containers. It basically just it's a managing service that you use Docker with to create containers. All right, guys. So that's it. That's enough of me saying all right for 1 hour, and you guys listening to my rambling. But I really do hope that you guys got something out of this session. That's the whole point. And if you guys have any suggestions, leave them in the comments. We'll try to get to them. And if you have any queries, you can always leave them in the comments later also. And if you like the session, please like and subscribe to show me the love. And I'll see you guys in the next session. My name is Ram, and I'll see you guys in the next session. Thank you for watching.